Download the free practice worksheet on this topic or take a practice quiz at Mathcation.com. Hello, ladies and gentlemen. Welcome back to another awesome math video from Mathcation. In today's video, I'm going to show you how to find the greatest common factor. As you can see, there are three important things we need to remember when finding the greatest common factor. The first thing we're going to do is we're going to factor both numbers into their prime factors. A prime factor is any number that can only be divided by itself. Common examples of this are 2, 3, 5, 7, 11. Now, when we factor today, I'm going to use the prime factorization tree, but there are multiple ways that you can factor numbers into the prime factors. After you have your numbers in prime factors, you determine which factors the two numbers have in common. This means you're going to look at the prime factors, you're going to see which factors are the same between the two numbers, and those factors are going to be the factors that you use. After that, you will multiply the factors that the two numbers have in common together. After you multiply, this will be your answer. So you'll take whatever factors they have in common, you'll multiply them together, and then after multiplying, that number will be your solution. And if you're learning anything right now, don't forget to subscribe so you don't miss out on other helpful math videos. Let's go ahead and get started learning about finding the greatest common factor. Now, this first practice problem asks us to find the greatest common factor between 12 and 40. What I'm going to have to do is I'm going to factor the number 12 into its prime factors, and I'm going to factor the number 40 into its prime factors. And like I said, I'm going to use factor trees to find the prime factorization. So I'm going to go ahead and factor 12 using the factor tree. So I'm going to factor out a 2, and 2 times 6 is 12. And then 2 is a prime factor. I don't have to factor that anymore, but 6 is not, so I have to factor 6 again. 6 is an even number, so I'm going to factor out 2, and 2 times 3 is 6. Now, 2 is a prime factor, and 3 is also a prime factor. So the number 12, broken down into prime factors, is 2 times 2 times 3. Now I'm going to do the same thing for the number 40. And the number 40, I notice the number 40 ends in a 0, which means I can factor out a 10, and 10 times 4 is 40. Neither of these are prime factors, so I have to factor them again. Well, 10 is an even number, so I'm going to factor out a 2. 2 times 5 is 10. Both of these end up being prime factors. And then for 4, we have to factor this again. It's an even number. I'm going to factor out a 2, and 2 times 2 is 4. So I know, and I already know 2 is a prime factor, so that's factored all the way out. Now, 40 listed in its prime factors are 2 times 2 times 2 times 5. Now, the way you get the greatest common factor is you will take the factors that both numbers have in common and you will multiply them together. So looking at these two numbers, both of them share this first 2, so I know I'm going to use a 2. Both of them share this next 2, so I know I'm going to use another 2. And then if you look at 12, we have the number 3, but there's no number 3 with 40, so I can't use the 3. 40 has an extra 2, which doesn't have a matching pair with the 12, so I can't use this 2. And 40 also has a 5, and 12 does not have a 5, so I cannot use this 5. So the only two factors I'm going to use are 2 and 2. We're going to say the greatest common factor is 2 times 2. And 2 times 2 is 4, so the greatest common factor between 12 and 40 is the number 4. And we got that by using the prime factors that the two numbers had in common. In this case, it's only 2 times 2. Moving on to our second practice problem. This problem asks us to find the greatest common factors between 50 and 20. So I'm going to go ahead and factor these using the factor trees again. So I notice that 50 ends in a 0, so I can factor out a 10. Well, 10 times 5 is 50. 10 is not a prime factor, but 5 is. So I have to factor 10 again. So 10 is an even number. I'm going to factor out a 2. 2 times 5 is 10. 2, 5, and 5 are our prime factors for the number 50. So I'm going to write 50 is equal to 2 times 5 times 5. Those are our prime factors for 50. And then I'm going to do the same thing for 20. I'm going to factor out 20. I notice 20 ends in a 0, so I can factor out a 10. 10 times 2 is 20. 2 is a prime factor. That's going to be one of our prime factors. 10 is not, so I have to factor it again. And 10 is 2 times 5. And both of those are prime factors. The prime factorization of the number 20 is equal to 2 times 2 times 5. To find the greatest common factor, I'm going to take all the factors they have in common and multiply them together. In the case of 50 and 20, they have a set of 2's that are in common, and they also have a set of 5's that are in common. Now the 20 has an extra 2 and 50 has an extra 5. They do not have a pair with each other, so you cannot use them. We can only use a 2 because they have a 2 in common and a 5 because they have a 5 in common. So that's what we're going to multiply together, 2 times 5. Now 2 times 5 is 10. So the greatest common factor between 50 and 20 is 10 because we use the factors they have in common and we multiply them together to get the number 10. And finally, the last practice problem gives us the numbers 48 and 80. I'm going to go ahead and factor these out using factor trees. And 48 is an even number, so I'm going to take out a 2. 2 times 24 is 48. 24 is also an even number, so I'm going to take out another 2. And 2 times 12 is 24, and the 2's are prime factors, but 12 is not. So I have to factor 12 again. 12 divided by 2 is an even number, is 12 and 6. That's going to be another prime factor of 2, and 6 is not a prime factor, so you factor it again, and that's going to be 2 times 3. And all of these now are prime factors. I know that 48 written out in prime factors is 2 times 2 times 2 times 2 times 3. For the number 80, we have to do the same process. I'm going to factor out a 10 because I notice this ends in a 0. And 10 times 8 is 80. Now 10 is not a prime factor, so I factor it again into 2 times 5. Both of those are prime factors. 8's an even number, so I'm going to factor out a 2, and 2 times 4 is 8. 2 is a prime factor, and then 4 you have to factor again into 2 times 2. So I'm going to list 80 out and its prime factors. It's going to be 80 is going to be 2 times 2 times 2 times 2, and then times 5. So to find the greatest common factor between 48 and 80, we have to multiply all the prime factors that the two numbers have in common. We're going to find all the pairs of matching prime factors. So 2 times 2, well, that's one pair. Here's another pair of 2's. Here's another pair of 2's. And finally, we have a fourth pair of 2's that all match up. For 48, we have the number 3, which does not have a pair in 80. And then for 80, we have the number 5, which does not have a matching prime factor in 40. So we do not use those. So to find the greatest common factor, I'm going to multiply all the factors that they share. In this case, they share 2 times 2 times 2 times 2. So they share 4 2's. And 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So the greatest common factor between 48 and 80 is 16 because we multiplied all the factors that the two numbers had in common and we got 16. And if you want to do some more practice on finding the greatest common factor, go ahead and click the link in the top right part of this video to get taken to a free practice worksheet download and a free interactive quiz that grades itself and tells you how you did. Thank you so much for watching. Please like this video if you got something out of it, and drop a comment telling me if this video helped you or if you need help with something else. See ya!